In the same way, you can find the Fourier transform for sine, not only minus. Okay. So first, this also you write using exponential. So you write this in terms of exponential using Euler's identity. E power j omega naught t minus e power minus j omega naught t divided by 2 or 2j. 2j. So for this entire equation, you apply Fourier transform. Okay. So left hand side it is f of omega. 1 by 2j I can write common. So Fourier transform of e power j omega naught t minus Fourier transform of e power minus j omega naught t. Now let me substitute the results. 1 over 2j. For the first term it is 2 pi delta omega minus omega naught. Second term 2 pi delta omega plus omega naught. So you can cancel this 2. You can take pi common. So pi over j delta omega minus omega naught minus delta omega plus omega naught. Or in some books what they do, this j you can take it to the numerator. So there will be a minus, right? That minus you just multiply inside. So first term will be delta omega plus omega naught minus delta omega minus omega. This is Fourier transform of sine omega naught t. Okay. See, any idea? For example, let me take this cosine omega naught t signal. After Fourier transform, okay, it becomes frequency domain signal. How do you plot this? How do you plot this? Let me write that equation. I think pi outside delta omega minus omega naught plus delta omega plus omega naught. How do you plot this signal? This is actually f of omega. How do you, what is the nature of delta omega? Only at the particular value of time or frequency? Frequency omega equal to 0, this is something like this. Now, this signal is advanced and delayed. Delta omega minus omega naught means the signal is supposed to start at 0, but it is delayed by a amount omega naught. This is delta omega minus omega naught. This one is, the signal is supposed to start at 0, but it is starting earlier, omega naught, by the amount omega naught. So it will be something like this. 0 minus omega naught. This is delta omega plus omega naught. But if you see, their amplitudes are pi. So overall f of omega, if I draw, it will be like this. Zero omega naught minus omega naught. Here there will be an impulse of amplitude pi. At minus omega naught, another impulse of amplitude pi. Okay. . See, this is with respect to omega frequency. Shall we go for the next one? Next example, you just note down. Switch on exponential function. See, this will be frequently using this signal. Say the switch is closed at time t equal to 0. So if you notice this function, it starts at 0, then when time increases, it is exponentially decreasing. Finally at t equal to infinity, this will become 0. So this function is basically called switch on exponential function. Have you taken the question? Have you taken the question? So this signal f of t is e power minus at u of t. So f of omega for this signal, see directly I am writing the integral limit because u of t is there, so I am writing from 0 to infinity. E power minus at, and the formula itself, it contains e power minus j omega t. Let me combine these two exponentials. Integral 0 to infinity e power minus a plus j omega into t dt. Integrate this signal. If I integrate exponential, same thing I will get. Divided by excluding the t minus a plus j omega. So the lower limit of t is 0, upper limit it is infinity. So minus 1 over a plus j omega, this is irrespective of t. When I substitute the upper limit, e power minus infinity, which is 0, minus when I substitute the lower limit, e power 0, which is 1. So this minus and this minus gets cancelled. So I will get 1 over a plus j omega. This is the Fourier transform of e power minus at u of t. Okay. Next example, switch off exponential. Switch off exponential. E power at. Leave out this 10. In general, you can take the maximum amplitude at time t equal to 0. 1 you can take. No need of 10. So just note down the question. Switch off exponential function. Okay. So f of t is e power plus at into u of minus t. So if you notice the signal, okay, is valid from minus infinity to 0. Okay. So f of omega, what is the integral limit? Minus infinity to 0, e power at, e power minus j omega t dt. In the same way, you just combine the exponentials, e power a minus j omega into t dt. Integrate this exponential, e power a minus j omega into t divided by a minus j omega. The lower limit of t is 0, upper limit infinity. Sorry, minus infinity to 0. Lower limit minus infinity, upper limit 0. Yeah. So 1 over a minus j omega, if I substitute the upper limit 1, lower limit e power minus infinity is 0. So Fourier transform of e power plus at, u of minus t is 1 over a minus j omega. So you can easily remember these results. If f of t is e power minus at u of t, what is the Laplace transform? If f of t is e power minus at u of t, Laplace transform is 1 over s plus a. Am I right? I said a relationship between Fourier transform and Laplace transform. Substitute s equal to j omega. You will get this result.